This is differentiating sine of x from first principles, and I'm just writing out some formula that we'll need for this equation. First of all is the double angle formula for sine. So sine a plus b equals sine a cos b plus sine b cos a. Next we'll need the small angle approximations of sine theta approximately equals theta, and cos theta approximately equals 1 minus theta squared over 2. And we'll also just need the box standard differentiating from first principles equation, which is f of x plus h minus f of x all over h. I'm going to start by writing out what my f of x is, and that's just sine x, because that's what we're trying to differentiate and prove. And then our f of x plus h is just sine of x plus h in the brackets. And then I'll go ahead and sub that into the first principles equation of f of x plus h. So we sub in sine of x plus h as f of x plus h minus sine of x as minus f of x all over h. Next, you can see that sine of x plus h looks a lot like the double angle formula at the top. So instead of a and b, we just sub in x and h. So it will be sine x cos h plus sine h cos x minus the sine x from before all over h. Now you can see sine x is in two of the terms, so you can factorize that out to get cos h minus 1 plus sine h cos x over h again. And next is where you use the small angle approximations. So wherever you have a h, you can change that into the small angle approximation because h tends to 0. So the cos h goes to 1 minus h squared over 2 minus the 1 bracket, and then plus sine h, but that just tends to h, so h cos x. I'll just simplify this numerator down before I put it all over h. So the bracket 1 minus h squared over 2 minus 1, the 1's cancel and just leaves a half h squared. So I'm going to put a half h squared sine x. And then the h cos x, the h cos x just stays the same. And now we put our limit of h tends to 0. I should have put this a bit further up as well. You should write it with all your workings. Anyway, now we can divide through by h. So that just leaves a half h sine x, that's meant to say h, I add that in a minute, plus cos x. And then the limit h to 0 again. So if h tends to 0, and we're doing a half h sine x, we're doing a half 0 sine x, that term just all goes to 0. So it just leaves us with cos x, and that's how you prove that sine x differentiates to cos x using first principles.